In this lesson, we're going to learn another theorem called the factor theorem, which is related to but different from the remainder theorem. So we use a bit of the remainder theorem in this factor theorem. So for example, in the last mastering questions that we just did, the question had said, is this a factor? And in order to say whether or not it was a factor, we had to test to see if when we plugged in the divisor, did it make a remainder of 0? So we're going to use that sort of in order to factor this. Now we can't factor this using any of our other methods. We might, there's 4 terms. You could try grouping, which I always do. When I look at this, the grouping isn't going to amount to anything that allow us to factor it. So what we're going to do is we're going to work backwards with the remainder theorem, saying, could I find a value for x that if I plugged it in here would give me 0, a 0 remainder? The problem with this method is you have to then try all the numbers on Earth. And what if there isn't a factor? And you're wasting your time and you're sitting forever and ever trying to find a factor. Well, the good news is the factor theorem tells us that yes, we look for a number that goes in here that will make this equal 0, because then we'll know it's a factor, and we can use that factor to factor the whole thing. But it's not all the numbers on Earth. The numbers have to be factors of the last number. So plus 24. Well, that's quite a few numbers, but nevertheless, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, oh my goodness, 12, 24. That's a lot to try, but it's less than infinite number, which you could have. So we'll be happy with that. What we're going to do first is we're just going to pick some we think it might be, or you can just start at 1 and keep going, but you're definitely going to need this friend. 1 I'm looking is not going to work because it has to add to 25. I'm going to try 2. Let's start with 2. Okay, so bracket 2 cubed minus 5 bracket 2 bracket squared minus 2 bracket 2 plus 24. Oh, let's hope it's 0. Oh, it's 8. Maybe negative 2. We'll try negative 2. Bracket negative 2 bracket to the power of 3 minus 5 bracket negative 2 squared minus 2 bracket negative 2 plus 24. Oh, let's hope this worked. Yes, it did. Through the magic of television, it was plus, oh no, sorry, it was negative 2. That worked. So we would write over here, how do we write this? We go, well, the polynomial at negative 2 was equal to 0. Therefore, what do we, like the negative 2 worked, that means x plus 2, remember the opposite sign, is a factor. So that helped us to find one factor. But what we want to do is find all the factors. We need to find everything that divides evenly into this polynomial. But once we have one factor, to find the other factor, it's easy. So for example, if we knew 3 is a factor of 15, how could we find the other factor? Be easy, because 3 times something is 15. 15 divided by 3 will give me the other factor. Same thing here. All I have to do is use this one, divide it by that, and I'll have the other factor. So it's going to be x plus 2. I'm going to divide. It's one factor. And I'm going to divide to find the other factor. Well, it's easy, except that we have to use division, which is not that much fun. Well, we'll go fast here. X squared. Multiply, subtract. Negative 7x. Negative 14x. Subtract 12x. Okay, we know it has to come out to 0, and that way you can check, see if your answer is correct. It did, so we know that that works. Therefore, my division statement would be x cubed minus 5x squared minus 2x plus 24 is equal to x plus 2 times x squared minus 7x plus 12 No remainder. So see how that's all factored. Beautiful. Except you always have to be careful that it's completely factored. So this one here, that's a trinomial. That might factor again. So let's get our man method going here. Multiplying to plus 12, adding to negative 7. So it's negative and negative, 4 and 3. And it's a simple one. So x negative 4, negative 3. And there it is, all factored. So when you want to use the factor theorem, first you got to go find the numbers using all the factors of the last number. You plug them in until you find one that gives you a 0. Then the opposite sign with your x will be your divisor. Divide using that wonderful long division that we all love so much to get the other factor, and then make sure you see if you can factor the other one. Okay, same deal here. We're trying to factor. It says use the factor theorem to factor, so we don't even have to decide if there's anything else to do. We just have to go ahead and find a number that will go in here and give us 0. So there's my polynomial. But this time at least we don't have so many to try. We can try plus or minus 1, plus or minus 2. All right. So plus or minus 1, plus or minus 2. It looks like 1 is going to work. So we're going to put that in there. 2 times 1 cubed, that's 1. That's also 1. Minus 3 times 1. Ah, yes. 0. Therefore, my factor is x minus 1. I like to write this at the beginning. It just makes it very clear to the reader what you're doing. Then what you're doing is x minus 1, dividing to find the other factor. Okay, and then 5x squared is plus 5x. Oops, I forgot to bring down my other one here. 5x squared minus 5x, subtract, becomes 2x, bring down the negative 2, hopefully plus 2. Here it is, 2x minus 2. Awesome, it came out to 0. So I know, therefore it factors to, you can say 2x cubed plus 3x squared minus 3x minus 2 is equal to, see how it's all nicely factored now? Plus 5x plus 2. But of course, we're not finished until we've checked to make sure. This may not factor, in which case we are finished, but it may factor, in which case we need to go further. So multiply, this is going to be a man method, but it's a complex one, right? 2 times 2 is 4, adds to positive 5. Those are positive. So positive, positive, 4 and 1. But because it's complex, we then have to divide them both by 2. So we get positive 2 over 1, positive 1 over 2. So positive 2 over 1, positive 1 over 2. And now I'm just going to put them back in here and we're going to be finished. So it's going to be x plus 2, 2x plus 1.